Hello. So we are continuing the titration of benzoic acid with potassium hydroxide. And we just talked about the pH at equivalence, which had gone up to 8.4. Reason being, at equivalence, it's really just a weak base calculation. So now we're going beyond the equivalence point. I want to calculate the pH after I've added 51 milliliters of KOH total. So I'm gonna call that calculation number F, and we can go down here to figure out what's going on in that case. So once I have added 51 milliliters total, I'm beyond equivalence, right? I have 0.051 liters of the 0.1 molar KOH, or hydroxide. That's really the important part. So that's equivalent to adding 0.0051 moles of hydroxide. Now remember, out of those 0.0051 moles of hydroxide, 0.0050 of them were consumed. So this is what I've added total. And the majority of them were consumed by the benzoic acid in the acid-base reaction. HA plus OH minus gives water plus A minus. So that leaves an excess of 0.0001 moles of hydroxide. These are going to be what's in excess. Now, this is a strong base. And because it's a strong base, this strong base will start to take over the pH of the solution, will control the pH of the solution. The weak base will contribute a teeny tiny amount of hydroxide to the solution, but it's so nominal compared with what the strong base is doing that we can just treat this as a strong base calculation. So we need to figure out what the concentration of hydroxide is in solution using that excess amount of hydroxide. So we have the excess moles of hydroxide over the total volume of the solution. Here the total volume is 101 milliliters because I've added 51 milliliters to the original 50. So that's how I get that denominator. It's the total volume of the solution. So this gives me a hydroxide concentration of 9.9 times 10 to the minus 4 molar. That's a molar concentration. To get the pH, I just take the negative log of that to get the POH of 3, and subtracting that from 14, I can find that the pH is going to be 11. So this is highly basic now because it's a strong base, and the strong base is going to be controlling the pH of the solution from now on in this titration. Whoops. So here's my chart. I don't have any moles of HA anymore, and I never will again as far as this titration is concerned. I do still have the 0.005 moles of benzoate, but I don't really need them to figure out the pH because really here and from now on actually it's going to be a strong base calculation. So I get a pH of 11. I want to also calculate what the pH is at 2 additional points in the titration just because I want to kind of extend that curve out a little bit. So if we look at calculation G and H at 60 and 100 milliliters of KOH, I'll just do one of those to show you what I mean. EFG. So 60 milliliters of KOH is going to be giving me 0.006 moles of hydroxide total that I've added. I hope that makes sense by now. Remember that 0.005 of them were consumed by the benzoic acid. So at this point in the titration, I have 0.0010 moles of hydroxide in excess. And that means that my hydroxide concentration is going to be equal to 0.0010 moles of hydroxide over a total volume of 110 milliliters now, 60 plus 50. So that's going to be 0.110 liters. That should give me a molar concentration of hydroxide that's equal to 9.1 times 10 to the minus 3 molar. Okay, so taking the negative log of that, you should get a pOH of 2.0, I think. And subtracting from 14, your pH is going to be 12. Plugging those values in to our data chart. Wow, we've done a lot. I get a pH of 12. You can do the exact same calculation for 100 milliliters of KOH. If you do that, you'll find that you have in excess of 0.005 moles of hydroxide, and you can put that over the new total volume, which in this case would be 100 plus 50, so 0.150 liters. And that will give you a pH of 12.5. So again, if you want to, you can just look back to the last calculation and just use the new numbers. So what's going on here is that, as you can see, we started out acidic because we had benzoic acid. This is our half equivalence point. At equivalence, we were dominated by the weak base. And then beyond equivalence, the pH shot up because hydroxide started running the show. But then eventually it kind of levels out. In the next video, we will plot this data in the form of a pH curve.